Hello and welcome to our Build-Up webinar organized by the Smart Build for EU project. My name is Karine Lafont-Elloire. I'm working from DOWEL Innovation, partner of Smart Build for EU, and I will be facilitating this webinar. Before we start, I will just shortly introduce Build-Up, our host. So Build-Up is an European collaborative platform. It's always updated and has key resources with key source on the topic of energy efficiency in buildings. You can register and become a member of Build-Up community, submit content as news, events, publications, new cases. We also invite you to navigate the portal. At the Learn section, you will be able to find the podcast of the past webinars. And at the end of this webinar, the recording and the whole presentation in PDF will be available in this section. So now let's start with today's webinar, during which 10 projects will be presented. So I will just quickly introduce the agenda of today. So we'll start with a brief presentation of Smart Build for EU, the project organizing this webinar. Then I will very shortly introduce the session. Then we will have the project's presentations with around 5 minutes per project. And finally, we will finish the webinar with a session of questions and answers. So please keep your questions until the end, and then you will be able to ask questions to all the projects. So Alexis David, project coordinator of Smart Build for EU, will now shortly introduce the project.
Yes, good morning, everybody. Thank you very much for joining this workshop. I guess, yes, I do have control of the slides. That's perfect. My name is Alexis David from ECTP, the European Construction Technology Platform. Thank you, Karine, for the introduction. My very brief introduction of the project Smart Build for EU will serve as a basis to understand better what we want to achieve, for example, with this workshop. So just in a few words, this project started about 5 months ago, and it will last 2.5 years. It was answering the topic support to the coordination of European Smart Buildings Innovation Community. So yeah, this idea of supporting the community, supporting the challenges concerning smart buildings, is really at the core of this project. You can see here the consortium. So the project is led by ECTP, as I said, with DOWEL Innovation, R2M, both in France, EURAC in Italy, and VITO in Belgium. And we are surrounded by a few other linked third parties, ASM, Cardiff University, the LIST, TNO and VTT, that are all bringing their respective expertise and their coverage of Europe in order to bring as many stakeholders as possible in this project. Just a few words to introduce the idea, the rationale behind Smart Build for EU. Well, as you most probably very well know, the building and the construction sector need to evolve. We need buildings to evolve from passive isolated elements to smart buildings that can adapt to occupants' needs, that behave as active node, and that are actually integrated in the different grids, in the energy grids and infrastructure grids. To achieve that, of course, we are facing a certain number of challenges. This is only a non-exhaustive list. We could have had a much longer list of challenges, but for instance, the market update of those smart technologies, the rollout of ICT and smart technologies is still quite slow. It's rather hard to engage with the building occupants in order to, for instance, make them understand the benefits of smart technologies, what it can provide them in their daily lives, achieve optimal building operation, integrate buildings into the energy market, and of course the high fragmentation of the ecosystem that is inherent to the construction sector, of course, but it is also related to the fact that smart technologies are referring to different levels, whether it is inside one building, whether we are considering the interconnection of buildings at district scale, at city scale, and so on. So that is really the basis for the reflection behind Smart Build for EU. We want to bring people together to consolidate and support this innovation ecosystem concerning smart buildings and to address the previous challenges and many others. We want to break silos, to share information among the different stakeholders and people we will put around the table. We'll organize a certain number of networking and communication actions to do that. We want to bridge the gap between innovation, the market, and the policy, since you will see that one of our objectives is to propose policy recommendations to improve the situation and address the challenges. And all this with a final objective to ground and to bring the basis to ground the future full-fledged smart building market in Europe. I will just very briefly show you the main activities of this project. So the first one is really to map and consolidate this community, this SBIC, as we called it, the Smart Building Innovation Community, with at its basis European funded projects, but not only. At a later stage, we will expand the coverage and not only EU funded projects. So bring people together, involve them in activities, and start making them exchanging. The second activity based on that is to bring the interested stakeholders around the table and to make them work on the challenges I was referring to before. So we have organized task forces, workshops, so that we can produce white papers addressing those challenges and proposing recommendations or solutions to progress in the smart building sector. The third activity is more technical. So I will show here the SRI. Smart Build for You is based very much on the SRI, the Smart Readiness Indicator that you probably know already. That is this common EU scheme for rating the smart readiness of buildings. We want to start on that and to go even beyond in order to list a certain number of core benefits. So what, in addition to the SRI, smart technologies, smart products can bring to the buildings. So that can concern as well the energy efficiency, the comfort of the occupant, the health of the occupants. So we want to address all this in order to really help understanding what are the benefits of smart buildings to the populations, to the building managers, and so on. We propose a certain number of technologies and packages of technologies that can address different situations depending on the building type and on the climate zone you are in. And finally, all these inputs will serve to provide a research and innovation roadmap. So again, addressing the challenges I referred to before, providing policy recommendations, and all this directed to both member states and the European Commission. For instance, how that can be, how the needs of the community can be addressed in the European framework, such as Horizon Europe. And of course, a certain number of communication and dissemination activities in order to promote our work and to promote all the initiatives that we will have encountered, to promote all the European projects we will have gathered around the community. So a few examples of promotion activities where actually today's workshop is really one of them. You will hear different presentations of several European projects that are really relevant in the sector of smart buildings. So that's our wish, to promote what is being done and to make those people exchange together in order to progress together. And some brochures, 3 brochures will be issued during the project, and the next one will be end of March, where again we want to promote smart building related projects. In the first phase, EU funded projects, and again we might extend this coverage to not only EU funded projects. So far we have around 40, actually much more than that now. It's more around 50 or 60 projects have registered. And if you would like to participate and to be part of this brochure, I can only invite you to click on this link over there and to propose your projects that we will then study and include in the brochure. I was referring before to the task forces, just a very short introduction to those task forces. You can see here the 4 main topics we have identified. All of these task forces is then divided in 3 subtopics. I have not showed them all, but if you're interested, please contact us. The idea behind that, again, is to bring specialist experts around the table to define together scopes of investigation, what are the challenges, the trends, the problems, and then to resolve them, to discuss them, to make a state of the art, and based on what already exists, to provide possible answers or possibilities for the future. And each of those task forces will provide white papers that we will then promote as much as possible. If you would like to participate in those task forces, please contact us. Karine Lafont from DOWEL, who was introducing this workshop, is managing that, and we will be most pleased to welcome you around the table. think that's it. Yes, that's it for me for this short introduction of Smart Build for EU. Karine, I guess the floor is yours to introduce the next steps of this workshop.
Thanks, Alexis. So today's webinar is the first of a series of 5 workshops to be organized in the next 2 years. And we hope that the next one will be held in face-to-face. The aim of these workshops is to share best practices and lessons learned with the community of projects, and beyond that, with the whole smart building innovation community. The results and innovation developed by the projects will also be key inputs to the work of the task forces presented by Alexis. And our next workshop, most likely a webinar again, will be held in June. So please get in touch to present your innovation or project. So what makes a building smart? The concept of smartness of a building has already been presented by Alexis, so I will just mention again that a smart ready service can provide several positive impacts to the buildings, its users, and the energy grid. The Smart Readiness Indicator Scheme, which was introduced by the revision of the European Energy Performance of Building Directive, proposes 7 impact criteria. First, energy efficiency, then maintenance and fault prediction, comfort, convenience, health, well-being and accessibility, energy flexibility and storage, and information to occupants. So the projects presented today focus on one or more of these criteria. As you will see, some of them are developing very specific technological building blocks, and others are delivering rather integrated solutions and services covering close to all criteria. Today we welcome 10 projects that are all related to smart buildings, but all with very different focuses and state of progress. So some of them are just starting, others are already finished. They will have only 5 minutes to present you their objectives and results. So that's very short and it's a very difficult exercise, but we'll have some time at the end of the session to answer the questions you may have for those projects. So we'll now start with the project. Dr. Bob Sander, over to you.
Thank you, Karine. So good afternoon, my name is Sander Smit and I'm working as a business designer and project manager for R2M Solution, one of the partners in the Dr. Bob project. The Dr. Bob project began in 2016 and ended in 2019, and the project demonstrated the economic and environmental benefits of demand response in blocks of buildings. The key idea was that blocks of buildings offer more flexibility in the timing and use of energy than single buildings. The goal of the project was to demonstrate that an integrated solution based on existing technologies could realize significant reduction in peak power demand, and that such a solution was economically viable. So we developed the Dr. Bob solution, as shown on the bottom right of the sheet. And the Dr. Bob solution is a scalable, cloud-based energy management system applicable to single and multiple blocks of buildings. And the Dr. Bob solution integrates the following 3 key components: a demand response manager as provided by Siemens, a local energy manager developed by Teesside University, and a consumer portal as provided by Gridpocket. So the local energy manager communicates with individual building management systems and generation and storage equipment within a block of building, and as such provides optimized micro-level energy management. Whereas the demand response manager provides macro-level optimized energy management, and the consumer portal provides the user interfaces required for energy management and community management. The Dr. Bob solution has been tested and validated in 4 distinct pilots, covering a broad range of organizations, end users, and energy markets. At Teesside University in the UK and the Technical University of Cluj-Napoca in Romania, the Dr. Bob solution has been tested in multiple university buildings. At the Fondazione Poliambulanza Hospital in Italy and the Arkinova Technology Campus of Anglet in France, the project has investigated the effectiveness of Dr. BOP in a hospital and a business park. All pilots encompasses a minimum of 3 different buildings. And as a result, the Dr. BOP demonstrated that up to 23% reduction in energy demand and up to 37.5% reduction in the difference between peak and minimum demand is achievable. The applicability of the Dr. BOP energy management solution to any given block of buildings depends on the technologies deployed in the buildings and their building management systems, the controllable assets within the buildings, and the availability of wider communication interfaces to enable telemetry and telecontrol signals with the demand response sponsor, for example, the DSO, TSO, or aggregator. So to enable building owners and managers to assess the applicability of the Dr. BOP solutions to their buildings, a method of assessing and validating the technology readiness of building stock to participate in the Dr. BOP energy management solution has been developed, the so-called demand response technology readiness level. At the point that our project was running, the SOI was not developed yet, and this is a more high-level way of assessing the technology readiness of your building. So we defined 4 technology readiness levels, ranging from no capability available to full manual and automated capability available. So what did we learn? What we learned is that for demand response to be successfully implemented in the blocks of buildings, it's essential to look beyond the technical and physical context of the buildings. 2 additional categories help to assess the extent to which a block of buildings can be considered ready for demand response Those 2 characteristics are market and organizational characteristics. So these 3 categories, technology, market, and organization, offer the possibility to assess what is needed for a good match between the demand response solution and the specific site. Another key lesson learned from piloting the Dr. BOP solution is that performance gaps can arise when the implemented solutions do not match with the real energy use practices of building occupants and building or facility managers. Attention must be paid to the current comfort experiences of the building occupants, the prevalent practices and routines of building occupants, the timing of demand response interventions, and the preferred ways of communication and engagement at the site. And finally, for the economic evaluation, the return on investment for the implementation of each pilot site has been calculated using a sensibility analysis for the countries with no demand response available market. And results shows that except for the French pilot, all other pilots have a calculated payback time amounted to 3 to 5 years of operation. But it must be said, these numbers can only be achieved when buildings meet the minimum technical requirements for supporting the Dr. BOP solution. This concludes my very brief overview of the Dr. BOP project. Thank you for your attention, and back to you, Karin.
Brilliant. Thanks a lot, Sander, for this very concise presentation. And now Juan Aranda will present the project Fresco. I'm not sure Juan has joined actually.
No, yeah. Yes.
Now here you are. Oh, perfect. Good morning, Juan.
Thank you for the presentation and for the invitation to this webinar. So my name is Juan Aranda. I'm the coordinator of a Fresco project. Fresco deals about the development of new business model for energy service bundles, and is addressing residential consumers. This project is led by Foundation Circe, and started just recently in June 2020. And it extends for 3 years. So we don't have results yet, but we are very positive on the results of this project. It addresses 6 of the 7 main smart readiness criteria. The objectives of the project is to come up with energy services that build upon the current existing EPC models of the ESCO projects for residential consumers, but try to enhance it with additional services based on a big data platform that will be developed and tested during the project. So these services will be delivered under a pay-for-performance principle that is based on a objective and accurate performance measurement and verification protocol that develops a continuous baselining based on real-time forecast upon the information or data gathered by the data platform system. So we are also assessing the smart readiness level of the buildings to retrofit buildings to make them smarter, more increase the connectivity and the capacities of the buildings for the delivery of these services that mainly have two aspects. One, energy efficiency. So the platform will develop services that will exploit implicitly and explicitly energy efficiency at home, either by automatically activating or deactivating the distributed energy resources at home. And the second aspect will be on the demand flexibility side. So part of this flexibility could be taken from the users. It could be segmented. It could be traded in available markets to provide services to the grid. So this provides a hybrid revenue system, one by the savings achieved with the energy efficiency services, another one coming from the flexibility traded by aggregated means from the domestic users, that this way they are allowed to participate in electricity markets whenever they are open. At the same time, part of the new energy services will deal about non-energy services that can be delivered by means of this big data platform, like comfort, like noise reduction, like air quality increase, or even surveillance and security in buildings. So the big data platform will ensure real-time data capture. We will also ensure data protection by encryption systems, and all this will respond to the current key regulatory market, socioeconomic and financial barriers to generate a new generation of new ESCO and aggregation services for the domestic consumers and prosumers. All these solutions will be tested in 4 demo sites distributed in throughout Europe, in Spain, France, Greece, and Croatia, where a number of domestic users will be engaged to test the big data platform and some of the services that will be developed along the project. So the idea with the project is to reduce, well, to increase the revenues from both sources, savings and revenues from the flexibility market, and this way reduce the contract duration and increase the profitability of the investments needed to create this big data platform. And this is basically the idea of the Fresco project that we are very confident that it will deliver good results in a couple of years, and I hope to be able to report these results and share them with you. Thank you very much for your attention.
Juan. connection issues on my side, so I hope you can still hear me.
Yes.
But now Ulrich Philippi will now present the Build Hub. Ulrich, you have to unmute yourself. I don't know if you're speaking or not. We cannot hear you for now. Yeah. Yeah. No, we cannot. We can still not hear you, Ulrich. Yeah, in case your mic is not working, Ulrich, maybe we can go to the next presentation and come back to you once this is solved. Or can you make a new try? No, okay. Then let's go to the next presentation.
You hear me now?
Oh, yes, now we can. Okay, so you can go back to your presentation. Perfect, thanks, Ulrich.
Okay, thank you very much. So hello to everybody, and thanks for giving me the opportunity to present Build Hub. Build Hub is a bit different than the other projects presented. It's a coordination and support action that started last year in October. The project duration is 4 years, and Build Hub is going to deal with the European building stock as a whole. This project is coordinated by me. I'm Ulrich Philippi from EURAC Research, situated in Italy. And this is a joint work with Technical University of Vienna, dealing with data analysis and analytics, with Avery's, an IT company dealing with the Build Hub platform, RISE, working on data analytics, machine learning algorithms, BPIE, Building Performance Institute Europe, working on stakeholder engagement, ICLE, dealing with communication and dissemination, CARDIFF, working on data analytics again, and also data access and licensing issues, and Simpraxis, dealing with the business model and exploitation of the project results. All or most smart readiness indicators are involved, but on a different level than for the big data projects. Here we are talking about the whole EU building stock, and we are working on national level and aggregated data level with yearly and annual, national data. So I'm trying to move to the next slide, but now, so this sums up what Build Hub is all about. The main objective of the project is to build a roadmap for sustained data flow from data providers on the European building stock to the Building Stock Observatory. The main goal of Build Hub is to act as a funnel. So we are going to develop a platform which develops services based on stakeholders' needs. And this so enriched data is then going to feed into the Building Stock Observatory once the new tender of the Building Stock Observatory is going to be published and will start. So Build Hub is also about engaging the whole community, all the stakeholders, asking for their needs. Once they provide data and metadata, these data are then going to be analyzed and processed. Build Hub works also on standardization of data, and this in collaboration with the big data sister projects, mainly Big Beyond and Matrix. And my last slide is going a bit more in detail about the objectives. So the main objective of most interest to the European Commission is a roadmap for sustained data flow to the Building Stock Observatory, to build and engage a community for data collection, data exchange, and data knowledge processes. to provide high quality data and metadata to the BSO, which currently has quite some gaps and some lacks regarding specification of metadata that need to be closed, to provide coordinated action among projects, especially the big data sister projects, Big Beyond and Matrix, and the standardized data governance and services. On the top right of the screen, you can see categories currently present in the Building Stock Observatory, and we are going to work on them and propose some new ones to the European Commission. As key results in the bottom left of the screen, you can see that we are working mainly on assembling different data sets, bringing them all together, making sure that we can work on them all together. So the data formats need to be standardized and the data model needs to be standardized. Then we need to provide insight through analytics, and the stakeholder engagement is very important. So to understand the needs of the stakeholders and to make them share data without providing money to them. So exclusively by creating added value through data services. The co-development of the platform is an important part through pioneer users and an ambassador program. And in the end, we want to provide a roadmap for the European Commission on how to shape policies and European directives to act on sustainable energy action plans, on long-term renovation strategy plans, national energy and climate plans, etc. So basically to move forward with the renovation wave and the decarbonization of the European building stock. With this, I conclude this very brief summary of the project's objectives. I thank you for your attention, and I'm of course available to any questions at the end of the session. Thank you.
Many thanks, Ulrich, for your presentation. Victor Martinez will now present the chess setup project.
Hello, good afternoon, everyone. Can you hear me?
Yes.
Okay. My name is Victor Martinez, and I'm the Urban Quality and Mobility Director for the municipality of Sant Cugat, one of the partners of the chess setup project. First of all, I would like to thank you for inviting us to explain our experience in the chess setup project. The chess setup project was a consortium with 12 partners and was coordinated by Barcelona Ecologia. Chess setup stands for Combined Heat Supply System by using solar energy and heat pumps, and try to respond to the increasing heating and domestic hot water demand in the public sector. Chess setup addresses the 7 indicators of smartness. I can move to the next slide. Can you move to the next slide, please? Yes. The project objective is to design, implement, and promote a reliable, efficient, profitable system to provide heating and hot water in buildings, mainly coming from renewable resources, in order to increase the self-sufficiency of the buildings and reducing the emissions. There were 3 different pilots, 2 here in Spain and 1 in the UK, in Corby. They were different pilots because they were the solution was implemented in different kind of buildings and different climate conditions. But all 3 pilots had the same solution, or at least have a common solution that I'm going to explain you right now. Here you can see in the bottom left side, the common solution is, or was, to install solar hybrid panels to generate heat to be stored and used for domestic heat, water, and heating, as well as to produce electricity that could be used in the building systems and appliances, and as well could be stored in batteries if needed. At the same time, we use in different modes, but there's 3 pilots who used a thermal energy storage tank or system that stores the heat collected by the panels, increasing the temperature of the medium. The medium could be liquid or solid. It depends on the pilot. There is 1 pilot using the solid as a medium. Another important part of the solution was a high efficiency pump supplying heating and domestic heat water
of the building, recovering the heat storage in the thermal energy tank. And of course, the system was connected to the building as well to the grid, because there were some kind of surpluses that could be, in some cases, that can be used for in the building, or if there are surpluses, they can be injected into the grid. Here in the bottom right side, you can see the system configuration for the pilot in Sant Cugat. The pilot in Sant Cugat was implemented in a sport pavilion with a large swimming pool, and we installed the system just to try to cover the energy demand of the swimming pool. We had to install a huge thermal energy storage tank with a capacity of 100 cubic meters. So it means that it was challenging to install this tank in an existing building as it was. We installed 160 hybrid panels on the roof of the pavilion, as well as we installed a buffer tank and the heat pump for sure. But we kept the backup boilers existing just in case the setup solution couldn't afford all the energy demand of the building. As a result, we can tell you that we are pretty proud of the results, because we have covered the 64% of the energy demand of the building. In summertime, we have covered the 100% of the energy demand of the building, but in wintertime, it's lower. Actually, I have to tell you that we don't have final results because of the lockdown due to the COVID. We had to close the swimming pool for a couple of months, so the results will be more tested in the coming months when we have all the installation working. Here you can see the 3 pilots. The pilot in Corby was installed in family houses, and the storage was installed in the foundations of each of the buildings. You can see here they took the most of the geothermal energy of the underground, and they recovered, or they reduced the energy demand about 46%, and they reduced the CO2 emissions around 85%. I have to tell you that this is the more flexible installation of the 3 pilots, because they have batteries to store the electricity produced, and they can manage when it's better to use this electricity from the battery or from the grid. The second pilot, the one in Manlleu, which was implemented in an office building, they use the building structure as a tank to store the energy that they collect or they generate with the heat pump overnight, because they overheated the underfloor heating system that they had, and they use this energy along the day. They use the structure as a short-term storage system, and they have reduced the energy demand around 47% and the CO2 emissions about 65%. And the third case is the one that I explained to you before, which is ours in Sant Cugat, that it covers the 7% of the total energy demand of the whole sport pavilion. I told you before, when I mentioned the 64% was only related to the energy demand of the swimming pool, and we have reduced the 10% of the CO2 emissions of the CO2 emissions. So that's a brief description of our project. We are pretty proud of it, and if you have any question, I will be available afterwards. Thank you for your attention.
Thank you very much, Victor. Maya Fanti will now present the project Plural.
Hello to everybody, and thank you for giving me the opportunity to briefly present the Plural project, which is a 5-month-old project with a duration of 4 years, and addresses directly 5 out of the 7 SRIs, and then directly the other 2. Plural is a project that addresses the needs of 6 different EU countries via a consortium of 18 partners, which you can see their acronyms here. The objectives of the project are to design, validate, and demonstrate a variety of what we call plug and use kits. It's a paraphrase of plug and play solutions that take into account the user requirements. The aim is to develop solutions for deep retrofitting of facades externally and or internally by incorporating renewable energy technologies in the prefabricated facade components. The target, the long-term target of the project is to reach near zero energy consumption of the renovated buildings with the different P&U kits. We aim to have a significant reduction in the costs and the timing for the deep renovation using environmentally friendly solutions that are flexible and adaptable. The project is focused around three core technologies: the so-called smart wall, which you can see on the right-hand side of the slide, which is a prefabricated panel that incorporates fan coils with smart windows that include ventilation into a prefabricated panel. The so-called EWHC, which stands for External Wall Heating and Cooling module. You can see here the representation. It's a prefabricated facade system that incorporates the heating and cooling piping that are driven by heat pumps that are also driven by PV modules installed either on the facade of the building or on the roof of the building. And the third core technology is called EAHC, which stands for External Air Handling Heating and Cooling Unit, which is another prefabricated module that incorporates thermoelectric modules with counterflow heat exchangers to modulate the air heat and cooling movement within the building. These three core technologies are enhanced and extended with a variety of materials like timber facades, ventilated facades, scene screens, aesthetic skins. We use in all three of them heat harvesting windows with ventilation functions. Special components are 3D printed. The windows are covered with low-E coatings and films, multifunctional coatings, antibacterial coatings, PCMs. So there is a variety of components that are added in each of these three core technologies to make it adaptable to the specific building conditions and climatic conditions. The design of the P&Us, of the plug-and-use kits, is done via a BIM platform, and we use big data management to store the data which comes from the monitoring of the building and of the facade components, and a decision support tool to optimize the design and manufacturing stages of the plug-and-use components. The demonstration of these innovative solutions will be done in three residential buildings in the Czech Republic, in Terrassa in Spain, and in Athens, Greece, and three virtual demo sites of different characteristics in Switzerland, Germany, and Sweden. As said, we have just started, and I'm looking forward to a closer collaboration with the rest of the panelists, as well as the organizers, to further promote the developments of the project. Thank you very much for the opportunity.
Many thanks, Maria, and thanks a lot for respecting the minutes of presentation. And for the rest of the speakers, as we are running a bit late, please don't forget to respect as well this 5 minutes. Dominique Cabiou will now present the DOMOS project.
Hello, my name is Dominique Cabiou. I am the project coordinator of the DOMOS project that started last fall and that will last over the next 3 years. As you can see on the right, I have said that DOMOS is about all of the 7 fields. This is at the same time the truth and the lie. It's a truth because DOMOS is about providing an environment, an ecosystem to develop and to operate services in any domain, typically in any of these 7 domains. But it's not the main focus of DOMOS of developing new services in this domain. In demonstrators, we will demonstrate services in all of these domains, but they are mainly adaptation of existing services. So the vision of DOMOS is to have an integrated ecosystem where you can connect, next slide, please. Where you can connect any smart infrastructure in buildings, and you can deploy any service making use of any type of smart infrastructure in building. Let's imagine if you have a smart appliance, a smart heat pump, for example, then you may you can imagine also to have a demand response application somewhere in the cloud. And the vision of DOMOS is that you can define, you can develop a demand response application for heating system that works on any type of heating system in buildings, because we have a mediation layer in between. So the objective of DOMOS, once again, is actually, this is the main objective that I did present. We have another objective, which is to be able to control and monitor existing building. This is quite a challenge because energy appliances typically have a very long lifespan, and many appliances date from the pre-digital area. And if we want to deploy quickly new smart services, we will have to consider those appliances, and this is part of our project. The second part of the project, this is really how you can have a decoupling layer between applications and in-building infrastructure. And for this decoupling layer, the goal is to avoid silo solutions, because we see on the market now many silo solutions appearing with many problems like difficulty of having several interfaces, the lack of interoperability between silo solutions. So, and also we want to have a focus on cybersecurity and privacy, where the citizen, where the prosumer can assign access right to its in-building infrastructure from a central point of control. Of course, to develop this interoperability, we don't start from a white sheet of paper. We rely on existing standards. To name 2 of them, first one is the Web of Things standards developed by the World Wide Web Consortium. And the second standard is the SAREF ontology. So this means that we want to have a unified way of naming things to promote interoperability. We will develop 5 demonstrators in 3 countries. There is a wide variety of demonstrators. So this is a wish to demonstrate that the ecosystem is not bound to a single set of applications. And also, you should not, what we developed is not a framework. This is an ecosystem that can be implemented over multiple platforms, and 3 platforms will be tested within demonstrators. Thank you for your attention.
Perfect. Many thanks, Dominique. The next project is Removal to be presented by Christina from CARDIFF.
Hello, good morning. Thank you very much for the invitation. First of all, I am Cristina de Torre from CARDIFF, coordinator of Removal project. Removal is one of the 3 first lighthouse projects funded by the European Commission. It started in 2015 and finished last year. 22 partners are involved in the project and 5 cities, Valladolid in Spain, Nottingham in United Kingdom, and Tepebaşı in Turkey as lighthouse cities, and Sagan in Belgium and Miskolc in Hungary as follower cities. Our goal was, sorry, I have to pass the slide, okay. Our goal was providing a model to make cities smarter and more sustainable. For this, we have developed an urban regeneration model that has been validated in the 3 lighthouse cities and tested in the 2 follower cities. This model, that you can see in the screen, is a methodology supported by several tools to transform cities into more sustainable and smarter ones. As you can see in this scheme, Remote One focused the actions in 3 main areas, energy, mobility, and ICT. But in this webinar, I'm going to summarize only the actions related to the energy pillar. The actions implemented in the 3 lighthouse cities could be summarized in these 5 main topics. District scale retrofitting, renewable heating and cooling, electricity distributed generation, monitoring tools for energy, and advanced building energy management system. For the 3 lighthouse cities, the main objective is to transform the selected districts in near zero energy districts. For this, the actions implemented have been selected to reduce the energy demand, the energy consumption, to increase the percentage of renewable contribution, and to reduce the CO2 emissions. In these slides, you can see some examples of the actions implemented in Valladolid, in Fasa district. On one hand, you can see the facades, the balconies, roofs were insulated. The existing district heating and the substations located in each of the buildings were renovated, and fossil fuels used were changed by biomass. In the south facade of the tower that you can see there, a photovoltaic ventilated facade was installed, and also lighting was upgraded in common areas of all the buildings. These interventions have been monitored, and energy management systems have been implemented at dwelling, building, and district level. And I have included the main results. As you can see, in Fasa district, the energy consumption has been reduced in 30%. There's also the 77% of the CO2 emissions. Currently, they are covering the 73% of the energy consumption with renewable sources, and they have reduced, this is very important also, the energy bill in 63%. In Nottingham, we have worked in the state of district. 465 dwellings have participated in the project. An energy sprung pilot was carried out in this district, achieving near zero energy properties. Here again, the envelope of the buildings was insulated, and they were connected with a low temperature district heating. Here, PV panels were installed on the roofs, and lighting was upgraded. Advanced control system and city platform were also implemented. City platform were implemented in the 3 lighthouse cities. And with these interventions, you can see they have reduced 40% of the energy consumption, almost 50% of the CO2 emissions, And the contribution of renewables in this case is 18 of the thermal consumption, and the energy bill has been reduced almost 50%. The third lighthouse city is Tepebasi in Turkey. In this case, again, the envelope was insulated, and in this case, triple glazing system was installed in the windows. Building integrated PV panels were installed on the roofs, removing tiles. And also PV panels were installed in a canopy structure, as you can see there in this picture. For covering domestic hot water demand, thermal panels were installed also on roofs. A district heating system has been implemented with biomass heating plant and with air source heat pump with a heat recovery system. Again, the same in the three lighthouse cities, we have installed energy monitoring and control system in order to measure CO2 emissions, to measure the comfort of the dwellings. And in this case, with this intervention, the 97% of the heating and domestic hot water consumption is covered by renewable sources, and the energy consumption has been reduced in 50%, and the CO2 emission is 54%, as you can see in the picture. The energy bill has been reduced in 56%. All this information is a very brief summary, but all this information can be found in the web page of Remo Urban, where we have included a best practice book with the main results of the project. So I would like to invite you to visit the web and to check this information more in detail. Thank you very much. Thank you very much again.
Thank you, Christina. And Sylvia Ura from Tecnalia will now present the Homes for Life project.
Yes, can you hear me? Yeah?
Yes, perfect.
Okay, good morning. Thank you very much also for the invitation. I am Sylvia Ura from Tecnalia, and we are coordinating Homes for Life project that started in December 2018 and ends this Sunday. So we are in the last days of the project. Homes for Life project is a coordination and support action also. And let's say that the long name will be Certified Smart and Integrated Living Environments for Aging Well. So it doesn't have so much to do with energy, but it has a lot to do with quality of life. Well, we all know that the quality of the living environments where we live has a big influence in our health and in our quality of life. And now in Europe, we have two challenges. One is the aging of the population in general, and also that the building stock that we have in Europe is not prepared to let us grow old at home. So we have to face these challenges. So Homes for Life project has been developed by a consortium of 9 different partners with different backgrounds, and that has been one of the strengths of the project, because we have research centers like Tecnalia and TNO. We have also universities like University Politecnica La Marque and Utrecht University. We have private companies like R2M and 30BEA, and we also have 3 associations, ECTP, the European Construction Technological Platform, Age Platform Europe, that is a platform representing the biggest amount of older adults associations across Europe, and Eurocares, that is representing the informal cares. So that is why this project is so well represented, because it has involved all the different parts. The objectives of the project were to develop an inspirational and realistic long-term vision and working taxonomy of the needs and requirements for the development of age-friendly living environments, to develop a functional brief for the development of Homes for Life vision that overcomes the gaps detected in different research and innovation projects and in the existing certification and labeling schemes, to develop and validate the Homes for Life certification scheme on the basis of that functional brief, and to deliver proof of increased future investment into age-friendly living environments. Now that we have already reached the end of the project, we can say that I think that we have achieved all our objectives. So the key results from our project are we have developed the Homes for Life vision, and it is a document outlining the sector vision at 2040. And intention is to provide guidelines and tools for stakeholders that have to create business and policies about age-friendly environments. Taxonomy and KPI definition methodology of age-friendly homes. It presents a structure and detailed breakdown of what it means for a home to be age-friendly, and the KPI framework uses the taxonomy as its structuring principle. And on the top of this, it has been developed the Homes for Life certification scheme. There is a new European certification scheme for age-friendly housing in Europe, and it is based in a long-term vision of people's needs and requirements, but based on a holistic life course, or Homes for All life course, and with a new conceptual framework for age-friendly housing. In the development of this certification scheme, we have been testing the different versions of the certification scheme in 11 different pilots. We did the first phase piloting with some of the pilot cases that were still in design, because the certification scheme intends to be useful for those buildings that have not been built yet, let's say that for new buildings, but also for existing ones. So the first version of the certification scheme was tested in those buildings that were still in design, and we did test it in 5 different pilot cases with different profiles of buildings. Some of them were co-housing senior initiatives, some of them were institutional housing solutions, some of them were private promoted buildings. And then after that, we developed the second one. And then what we did was to test the second version in another set of pilot cases that were already running. There were buildings and initiatives that were already, let's say, inhabited by people that was living there. So I invite you to check our webpage. You have there all the information. You can join us in our community of interest, and you can have access to all the developments and all the work that has been done. So thank you very much.
Thank you, Silvia. Roberto Lolini will now present the project for R2M.
Thank you, Karine. My name is Roberto Lolini. I'm coordinator of Energy Efficient Buildings group in EURAC Research in Bolzano. I'm the coordinator for our new project. We are in the final phase of the project that will be finalized at the end of June this year. Okay, maybe I'm trying to move to the next slide. Okay, so the main objectives of our new project are tools and methods for deep renovation of existing residential building, and through these tools, methods, and technologies we developed to encourage large-scale renovation of existing building stock. So the main results are aimed to support building deep renovation through knowledge-based decision process for increasing building users' well-being. So this is the starting point of our process, provide knowledge coming from the processing of data and information collected in the existing buildings. Then the optimization of the investment, considering energy, environmental cost, energy, environmental, and cost in the life cycle, sorry, as well as renovation time. So something related to the direct impact of the building, but also the impact on the users that we would like to reduce. The idea is to have a sort of circular approach. So starting from the auditing, collecting information, using this information to optimize the technology solution packages, and then implement the solutions also through a proper action to make the final user aware of what is happening in their buildings, and then continuously monitoring what is happening in the buildings in terms of energy, in terms of indoor environmental quality, and so on and so forth, just to optimize also the maintenance during the operational phase, and preparing the next deep renovation, and so restarting the cycle. We have 4 pilots in Norway, the Netherlands, Spain, and in Italy. I will present in the next slides. Our main target was to reduce up to 60% the energy consumption while keeping a high indoor environmental quality. And considering also the construction time and reducing this construction time 50%, and reduce also the impact in terms of environmental impact and economical impact during the life cycle. And the base of our, let's say, packages are the modular and prefabricated component systems, starting with the prefabricated timber building facade, integrating different elements, windows, PV panels, ventilation units, and so on and so forth. An hydronic module to optimize the existing distribution of energy, so also introducing, I don't know, a new solar collector panel fields, and so on and so forth. Then smart ceiling fan to reduce the need of active cooling system, so moving air in order to increase the comfort situation in between seasons, or in summer where it's not too hot. And last but not least, a tool to optimize the harvesting of renewable sources. So kind of sources to be used and kind of application or integration in the building envelope of PV or solar collectors, or openings to use actually the natural sources. The demo cases, as I said, this is in Norway, so mainly dedicated to facade and ventilation. In the Netherlands, again, facade and internal energy distribution system. Spain, still ongoing. We are, or I mean, the manufacturer is producing the prefabricated facade system that will be installed in the next few weeks. And in Italy, where the focus was on the hydronic unit, so this plug-and-play energy hub that we install in the apartments, and also the monitoring system that we install in the apartment to also check and assess the indoor air quality in terms of chemical pollutants. What we are doing now is to define the assessment of the actual saving. So using the approach defining by the standard and implemented in our project. So defining a baseline and a proper model, and then compare the actual situation with this model as it was working in the same period of the renovated building. This is what we are doing now in terms of impact for energy saving, and we are also calculating the other impacts in terms of improving of indoor environmental quality. We are post-processing what happened in the construction side in terms of timing and impact on the users, just to provide an overview of our deep renovation approach. And that's it. Of course, I'm available for any question or any contact. If you go to our website, you can find a lot of information about what happened and what is happening in the project. Thank you very much.
Thank you, Roberto. Thanks a lot. And last but not least, before our Q&A session, the heart project will be presented by Claudio Del Pero. Claudio, don't forget to unmute yourself.
Yes, good morning to everybody. So I will present HEART project. HEART stands for Holistic Energy and Architectural Retrofit Toolkit. It's a project coordinated by Politecnico di Milano that started in 2017 and will end in the spring of the next year. This project is okay, sorry. This is the next slide, sorry. The project has several objectives. The first one is to develop systemic and cost-optimal solution for the energy retrofit. So we would like to put together different complex technologies to achieve the energy retrofit of a system building. The objective number 2 is to update and adapt innovative technologies for their systemic integration. So we are starting from existing products, existing components that are normally used for the energy retrofit, and we are simply adapting them to making them working synergistically together. Objective number 3 is to foster buildings smart upgrades, so to transform existing building into smart buildings. Objective number 4, to support and improve the decision-making process, because together with the hardware technologies, we are also providing a software tool, a cloud platform that is able to support the decision-making process to identify the best retrofit strategy for a specific building. And then objective number 5 is to promote energy efficient financing tools to give particular business model to support the retrofit of a system building. The toolkit is composed by 9 different elements: multifunctional external thermal insulation, some retrofit components for existing windows, a universal photovoltaic tiles to generate renewable electricity, a cloud platform, some DC smart fan coils that are replacing the existing radiator, a thermal storage to store thermal energy, a battery pack that is not a component developed within the project, but is just integrated in the other technologies, direct current heat pump, centralized heat pump, and the last is a multi-input, multi-output converter that is managing all the energy fluxes within the building and also interfacing the building with the grid. In the project, we have 2 different case studies. The first one is in Bagnolo on Piano, close to Reggio Emilia in Italy. This building is currently under retrofit and the works are almost finished. So the idea is to have the building ready for the late spring. And the second case study is in Lyon, in France. And in this case, we are now finalizing the design of the retrofit intervention, and the works will start in a couple of months. So we had some delays due to the coronavirus situation, but in any case, we hope to complete both case studies within this year. So thanks for your attention, and I'm available for any question.
Thank you very much, Claudio. So we now move to our Q&A session. So I don't know if we have any question from the audience. Build-up team, can you help on this? I cannot see them myself. No, okay. So we received just a kind of connection request from the Onto Commons project. So just to let you know that we have seen it and we'll put you in touch with Dominic from the DOMOS project, no problem. So since the audience seems to be a bit shy today, I will start with the questions I have prepared in the meantime. And if you come up with other questions, please put them in the question box. Okay, so I will start with a question for the project Chess Setup Plural for in EU and HEART. How can you guarantee that the systems and solutions you have developed or will develop are interoperable with other existing and more specifically also with future installations. So we can maybe start. Who would like to start? Maria, Roberto, or Claudio?
I was speaking, but I was muted. Sorry.
Ah, okay.
I can start. Yeah. To be honest, the interoperability was not a specific, let's say, topic in our development. But anyway, what we try to do is to have, let's say, a place where to put all the data. And this data could be also available for future development. So we developed what we call it sensible data handling. That is, let's say, as a backend is a database of data, and on the other side is a way to show this data to the final users, to the facility manager, to different possible stakeholders. And of course, from technical point of view, we develop a specific interface, a specific API, in order to make available this data following these communication protocols. This is for the data part related to the, let's say, technology solutions, the hardware part related to the prefabricated facade. We push quite a lot on digitalization of the process, and this should, let's say, make easier the future maintenance and the future possible integration of other components. That's what we did. Thank you.
May I add a point? I would say the DOMOS project deals exactly with that question: how to decouple applications from the field infrastructure. And well, I mean, I cannot develop that here because it's a topic per se, but this is really the goal of the project. And if you are interested in that question for any project here or for any auditor, please get in touch with me or with my colleague.
Okay, thanks, Dominique. Claudio, Maria, do you have anything to add on that specific topic?
May I speak? Yeah. Well, from my point of view, I would like to say that it is very difficult to develop a universal solution. We all know that any kind of technological solution is dependent on a long list of parameters that need to be addressed to develop solutions that lead towards net zero energy buildings and buildings with zero carbon footprint. There are methodologies which can be developed and followed to harmonize the requirements and have a good overview of the needs of the projects, of the buildings. Sorry, but I'm sure that Dominique, through the DOMOS project, has a much better overview of this. But I believe that there is still work to be done, and we will need harmonization of the results of the different projects in order to be able to answer this question reliably. Thank you.
Thank you, Maria. Does anyone else want to add something on this one? Otherwise, I will just fire my other questions.
Sorry, this is Victor from Sant Cugat. Can you hear me? Because I had a problem with
Absolutely.
my...
We can hear you now.
Okay, because I was on mute. I was mute and I couldn't unmute. So in my opinion, the problem we had about interoperability with existing installations and the buildings, it was one of the main issues of the project, because we were working in an existing building with an existing installations, and that's what it was very tough work for us, and we were very careful about what system and what kind of monitoring system or what kind of data do we need to measure in order to make it feasible, the interoperability of that. And the proof that we have succeeded is that nowadays we are improving the result of the CESAT project with another European project, which is Integrity, and we are not having any problem of interoperability. But I have to tell you that it was an issue that we had to deal with, and it's important to make sure that everything you carry out in your buildings won't bring you more problems than solutions. But we were able, but in another European project that we were taking part, it was very difficult, and at the end of the project, we weren't able to sort out the problem of interoperability.
Okay, thank you, Victor. All right, my second question was, how can we ensure that the smart buildings are inclusive, that they answer the needs of all occupants, and in particular the elderly? So I think this is more that the Homes for Life project will be the more relevant to answer this question. Hi, Sylvia.
Yes, hi, thank you very much, Karin. Well, I think that what we have to think is that the buildings have to be able to adapt to the needs of the people that is living in them. So I think that we have to start thinking on homes that have the availability to make changes and to adapt to the changing needs and abilities of people that is living in them, not just the older citizens, but all the citizens in general. So I think that is key to thinking that all the solutions that we develop have to be able to be adaptable to the needs of the people.
Okay. Okay, you mean that those needs are likely to change in the coming years, and that the solutions should be able to adapt as well. Okay.
Yes, not just let's say construction solutions, or also technical solutions. I mean, all the infrastructure that we are now introducing in the buildings have to be able to give the option to adapt those buildings to the needs of the people that is living in them.
Okay, thank you. I then have a quite a tricky question. So, according to you as partner of a European project, what is the main barrier to making existing buildings smarter? So I guess there are loads of barriers, but according to your experience, what would be really the main ones? Maybe we can start with Remoban, because you had a lot of demonstrations.
Yes, as you say, there are many barriers sometimes, but for us, one of the most important barrier, mainly in Spain, in Valladolid, was the involvement of the people, of the owners of the buildings. In our case, citizen engagement activities was very important. In fact, I think they are essential when we work with private buildings. If the owners don't agree with the project, the planned actions cannot be carried out. So in our case, particularly in Valladolid, in Spain, we have to do a great job of citizen engagement. We talk almost with all owners, because at the beginning, they were not sure about participating or not in the project. So this is a very big barrier when we want to do things to actions in private buildings. I think there are more barriers, or maybe difficult technical barriers sometimes. But I think in this case, this kind of barriers, the social barriers, are very important, because if owners don't want to participate in the project, you can't do anything. So I think citizen engagement activities are very important, and they have to take into account in all these kind of projects.
May I add a point?
Yeah. Mm-hmm.
Well, I mean, this is an easy answer in some way, because if you do not convince the owner, it means that we do not have a good product. I mean, to make it very to say it very simply, yeah, and very abruptly. I mean, so I think we really have to think on the product and the service we offer and the ratio and why the users do not want to be involved in the service that we want, because it's easy for us to put to say the user does not want it and this is the fault of the user.
Okay, thanks, Dominic. I now have a question for Alexis that we received from Alexander Delianis from Synpraxis. Smartness seems to be viewed from various perspectives by the various projects, which is good. For instance, at building level, block level, etc., and so on. Is it the intention of Smart Build for EU to define a framework for linking the various smartness approaches?
Right. Well, first of all, thanks for all the interventions. And indeed, I do agree. We see different perspectives, way of taking the problem, different aspects, challenges, and so on. So it's indeed very interesting. And that's only 10 projects around the table today. So they think about all the other projects who are going together and that are going to bring their views as well. So yes, indeed, Smart Build for EU has as an objective to bring all those experiences, knowledge together, to learn from each other, and indeed to tackle issues, to tackle challenges, maybe not all of them, but to tackle the most challenging one within the different activities we have proposed. So for instance, the different experience learns about interoperability that we were just discussing. That would be extremely important in the task forces. That is actually one of the main topics of the task forces that we're going to discuss. So yes, indeed, we want to have the different inputs brought together in order to address the challenge in the most complete way, and hopefully to provide the right answers to enable interoperability among all the project, all the activities and technologies that will be put on the market. And yeah, again, learning from each other. We've just been hearing about how to involve people. I guess we can learn from different projects, in particular remote urban. Again, that would be another important topic that we want to include with the different perspectives inside our task forces and the rest of the project.
Thank you, Alexis. Well, it's already 1:30, so I suggest we close the meeting now because we haven't received other questions. And it's nice to close on these very nice words from Alexis as well. So thanks a lot to all the participants, and a warm thank you to all our speakers. Thanks again for participating. And so we'll keep in touch and invite you all to our next webinar, which will take place in a few months. So with that, I would like to close the meeting and wish you a bon appétit.
Thank you, Karine. Thank you, everyone, for your.
Thank you.
Thank you, everyone.
Bye.
Thank you. Bye.
Bye.